The fraction buster technique uses two ideas in order to eliminate fractions from equations. It kind of simplifies the solving of the equation then because you don't have to deal with rational expressions. One of the ideas is that if you have, and I'll just write this over here, if you have, for example, like 3 divided by 5 and you multiply that by the number 5, right, this becomes 15 over 5, or you can write it as 3 times 5 over 5, and this common factor of 5 is eliminated. Now, that's all well and good, but you can't just go around multiplying things by 5 because you change fundamentally what they are. However, in an equation, because we have two sides, we have a left-hand side and a right-hand side, we can multiply both sides of an equation by the number 5, and we don't change the equation or its solutions. Just think about this, for example. If I have the expression 3 equals 3, and I multiply both sides of that expression by a factor of 5, right, what I end up with is the new expression 15 equals 15. 3 equals 3 was fundamentally true, right? And because I multiplied both sides by 5, 15 equals 15 is also fundamentally true. The other thing that happens when we do this is we don't change the value of x. We end up finding the same value of x. We've just changed how the equation looks along the way. So these are the two ideas that we use when we're using the method of fraction busters. So let's come back to our original problem here. I've got x over 6 equals negative 5/8 over 4. Now, if I wish, I can go ahead and begin by multiplying both sides of this equation by the number 6. When I do that, I have to be very careful. Every single term on both the left and the right-hand side needs an additional factor of 6 in order to not change what it is. Remember, terms are those things that are separated by plus or minus. And actually, maybe I should explain this idea a little bit more. So for example, if I have 2 plus 3, and on the other side I have that equals the number 5, if I want, I could multiply both sides of this by 6 and not change the answer. So if I come along here, I'm going to say, look, let's add a new factor of 6 to this side, and I'm going to add a factor of 6 to that side. What I end up with now is on the right-hand side, I just have the number 30. And on the left-hand side, I'm going to go ahead and distribute this 6 to both of them. I'm trying to suspend that addition to show you the truth of this technique. Well, 6 times 2 is 12. That's the distributive property. What I just did is I added a factor of 6 to this term, and 3 times 6 is 18. I just added an additional factor of 6 rather to that term 3. Well, when I add 12 and 18, I do indeed get 30. And we can see that, yeah, if I'm going to multiply both sides by 6, I have to make sure I get every single term on both the left and the right-hand side by the 6. Okay, so now back to our problem. So each term is going to get a factor of 6. So if I rewrite this, this would become x times a 6 over 6 minus 5 times 6 over 8, and then that equals the number 6 times 4, or 24. So first of all, the immediate thing I see is that I've eliminated the factor of 6 from my first term entirely, and this becomes x minus. Now, interestingly enough, if you take a look at this next term can be simplified because both the 6 and the 8 have a common factor of 4. In fact, if I was to, I could eliminate that. 2 times 3 is 6, so this would be a 3 if I eliminated a factor of 2. And 8 times 2 is, I'm sorry, 4 times 2 is 8, so this would be a factor of 4. So in other words, what I've done is I've eliminated the common factor of 2 that both 6 and 8 have. Well, when I rewrite this now, this becomes 15 over 4. And that equals the number 24. Now, to be honest, at this point, you could proceed and just kind of solve this without worrying about eliminating the fraction completely. Or you could go ahead and multiply both terms by 4. Because I'm practicing fraction busters, I'm going to go ahead and multiply both sides by 4. And when I do that, this equation becomes 4x. Oops. And then just simply minus 15, right? 15 times 4 over 4 is 4. So I've eliminated the fraction there. And then the next thing I've got to do is multiply 4 times the number, 4 times 24. So that's the number 96. 4 times 24, 48 times 2. And then I'm going to add 15 to both sides, and I've run out of room. If I add 15 to both sides, I believe that is on the right hand side rather, I'll have 111, and the right hand side I have a 4x. And this is not very satisfying, but my solution is that x is equal to 111 divided by the number 4. And by the way, considering that you have your TI-84 calculator, 83 or 84 or 83 plus, whatever you have with you, it's a really good idea to take that 111 divide by 4, and then take that and divide by 6, and then after you've done that, maybe press enter and then hit subtract 5 divided by 8 and press enter. If you indeed get 4, then you've just verified that x is indeed 111 over the number 8. So we've got one additional example here. In this equation, we have obviously fractions in two places, right? The first term on the left-hand side and the right-hand side both contain fractions. And on the left-hand side, our fraction actually contains a variable down in the denominator there. That is a really good time to use fraction busters because there's just a lot of goofy mistakes people make, if I leave fractions down in my denominator. So I'm going to multiply both sides of this equation, every single term on both sides, by 8x. When I do that, this becomes 5 times, here's my new 8x, over x minus 2 times, here it is, 8x, and then equals negative 11 times 8x, and then over and 8. So each term on the left-hand side got a factor of 8x, and they're all placed in the numerator. If there was a fraction already existing. Now you can see I can go ahead and eliminate my common factor of x on the left-hand side, and over on the right-hand side there's a common factor of 8 that we can eliminate. When I do that now, this equation becomes 40 minus 16x, and that will equal, let's see, negative 11x. So to solve next, I guess what we're going to do is I'm going to add 16x to both sides. So when I do that, that will eliminate the 16x that's over on the left-hand side. So this equation now will become 40 equals, let's see, 11 and negative 11 and positive 16 should be 5. So I've got a positive 5x. And then finally, I'm going to just divide both sides by 5, and I get that 8 over here is x, so I would write x is the number 8. And again, if I take that value 8 and I plug it into the original problem, right, 5 over 8 minus 2, and look at that as a decimal and compare that to a negative 11 over 8, they should be absolutely identical. The left and the right hand side should be the same if this is indeed the solution. So that's it for fraction busters.